In section 8.3, we will learn about the t-test. So the t-test is used when testing the mean and the population standard deviation sigma is unknown. Most likely we are not going to know sigma, the population standard deviation, when performing a hypothesis test for the mean. Typically in this situation, the sample size is small. So therefore we have to use the t-test in this case. So let's go through the process of performing a t-test, and it mirrors that of the z-test with some slight modifications. So here is an example. It has been reported that the average age of NBA viewers is 42 years old. In Los Angeles, a researcher for the LA Clippers organization feels that the average age of NBA viewers is significantly less than 42. She collects a sample of 10 NBA viewers and finds that the mean age is 35. And the sample standard deviation is 5.8. Use alpha equal to 0.05 to test her claim. So right away that tells us we do not know the population standard deviation. We only know the sample standard deviation, S. So whenever we perform tests for the mean, we should always ask ourselves, do we know the population standard deviation? If the answer is yes, we use the z-test. If the answer is no, we use the t-test. Another clue is that for t-tests, we typically have a small sample that we're working with. So that's step one. Step two is we state the claim and determine H naught and H sub 1. Well, the claim is that the mean is less than 42. That's H sub 1. H naught is always the mean equals to, in this case, 42. We draw the tail area of the test point. Okay, so we draw our t-distribution. It's a left tail. And since we're looking up a t-value, we have to compute degrees of freedom, n minus 1. So n is 10, so n minus 1 is 9. So let's now go to table F. Now we use our t-values. So it's a one-tailed test, 0.05 is alpha. Go down to level 9, degrees of freedom of 9. Our critical value is 1.833. And since it's to the left of 0, we make it negative 1.833. Now we compute the test point for t. So this formula is very similar to our z formula. The main difference is that sigma is now s. S is the sample standard deviation. So our sample mean is 35, population mean 42, sample size is 10, S 5.8, we perform our calculations, the test point is negative 3.82, and we compare that to our critical value, so thus our test point falls in the critical region, so that tells us to reject H naught, and then we use our chart to summarize the results. So if we go back to the claim, it was H sub 1. So we focus on the H sub 1 column. We reject H naught, so our summary will be there is enough evidence to support the claim. And then I have a few problems for you to try. But let's go ahead and take a look at another example. So in this example, it says, assume that data is collected to test a claim that the average amount of coffee cups that a college student drinks per week is greater than 15 cups of coffee per week. Using a level of significance, that's another phrase for alpha, of 0.05, a researcher collects the data below. So perform a t-test for the claim. So we are given these data values. Our first step in this case is to use our calculator, and I've made videos You can look them up on YouTube or in past modules to compute the sample mean and sample standard deviation. So that should be 16.5 for the mean, 6.54 for the sample standard deviation. Okay. Now we state our claim. So the claim is greater than 15 cups. So mu is greater than 15, that's our claim. That's h sub 1. H naught is mu equal to 15. It is a t-test because sigma is unknown. We know S, not sigma. Compute degrees of freedom. There's 10 data values minus 1 is 9. Our alpha, if we go back to the problem, is 0.05. So we turn to table left, go down to level 9, one tail 0.05, 1.833. In this case, it's positive 1.833. Now we will compute our test point formula and then make a decision. So we calculate our test point formula. We have t is equal to the sample mean, 16.5, minus the population mean, 15, times sample size of 10, there are 10 data values, divided by the standard deviation of the sample, 6.54. Subtract first, that's 1.5, and then we perform our calculations, and we have t is equal to 0.726. That will fall short of the critical region, so it will fall in the non-critical region. So we do not reject H naught. So let's now turn to our summary. So our claim is H sub 1, but now we do not reject H naught. There is not enough evidence to support the claim, and that's our summary. And that concludes our video for section 8.2, the t-test.